Okay, I'm going to do step A in blue and step B in green. Okay, so for this one, anytime we have a rotation, I really think a rotation is easier to do with the rule. So that more algebraic approach with your ordered pairs. So that's what I'm going to choose to do here. On the front, I showed you, you can do graphically or you can do like the algebraically. So I'm going to do algebraically with a rotation. So I'm going to list my 3 points. I have L, M, and N, which are at 0, 3, 3, 4, and 1, 2. Okay, so these are the original pre-image points. Okay, and then point A says 180-degree rotation about the origin. Notice it doesn't say clockwise or counterclockwise because 180 degrees doesn't matter. The 180-degree rotation is the same whether you go clockwise or counterclockwise. Okay, and the rule for that 180-degree rotation is that your xy becomes negative x, negative y. So when you do that 180 rotation, you are switching the sign of both the x and the y. Okay. So my new L prime, M prime, and N prime, I'm going to take all of these and switch the signs. Now, does 0 have a sign? Is 0 positive or negative? 0 is neither. So 0 stays 0 if all we're supposed to be doing is changing the sign because it doesn't have a sign. Okay, but that 3 will become negative. That 3 will become negative. 4 will become negative. The 1 and the 2 both become negative. Okay, so that's the rotation. Okay, that's part 1 or step 1 of this composite transformation. Now part B, okay, it says translate using this rule. So that is adding 1 to the x and adding or subtracting 1 from your y's. So I'm going to take all of my x's and add 1. So this will be 1, negative 2, and 0. I'm going to take all my y's and I'm going to subtract 1. So this would be negative 4, negative 5, and negative 3. And those would be my final points after the composite, after both transformations. Notice I didn't plot a single point, did I? Because I used the algebraic approach. I didn't have to plot the points. You can. Obviously, if it's a question that tells you to graph, you have to graph. Okay, there will be both types of questions where you maybe have to plot points or give ordered pairs. Okay, you have to be able to do both. Okay, but if they don't specify, you get to pick how you do it. Does this make sense? Yeah? Okay. All right. Because I'm recording this, I'm going to go ahead and do number 4 also, but you do not have to follow along if you want to go ahead and get started on your practice. It's a Delta Math. You can go ahead and get your laptops out and start the practice if you think you have a good understanding of this and are ready to start. If you feel like maybe you need to see one more example, I'm going to do example 4 and record. Okay, so since I'm recording, I need you still not to be having conversations, just working quietly if you're not following along, okay? So in number 4, we have a parallelogram. So we've got 4 points this time. Okay, it's a reflection and then a translation, which we did on the front, reflections and translations. I would probably do this algebraically as well because of the reflection being the line y equals x. It's not just a up and down or left and right reflection like on the front. Okay, you're not just going over the x-axis or y-axis. You're going across the line y equals x, which, as a reminder, if you have forgotten, the line y equals x goes through the origin at a slope of 1. That's the line y equals x. So that's what we'd be reflecting across. I'll actually, since I'm doing this as a video, I'll do both. I'll show you graphically and algebraically. So graphically, I would need to plot the original parallelogram. So I'm going to accentuate my x and y axis real fast because it's kind of hard to see those. There's x. That'll look better on y. There's y. Okay, so I'm going to plot my points for the original. C is at 2, -1. The original D is at 7, +1. E is at 6, -2. And F is at 1, -4. Yeah. Okay, so here's the original parallelogram. And my first transformation is the reflection across that line, y equals x. Now, on the front, when we reflected, if we were going across the x, like see how C was 1 below, we just went 1 above. Okay, or if we were reflecting over the y, F is 1 to the right, so we'd go 1 to the left. But since it's at this diagonal angle that we're reflecting across, if you're doing it without the rule, if you're doing it graphically, okay, you will need to count kind of like how you are from the origin to your point. See how you went right and down? And we're going to have to split that. Instead of right 2, down 1, we're going to go right 1, up 2. Okay, or actually, it was right and down. So the opposite is going to be up and left, actually. What the rule says you're doing is you're switching your x and your y. So instead of 2, -1, you're going to go -1, 2. Okay, so that's what happens. So that C is going to be here. So it is a reflection directly across it, but it's at a diagonal. So it's kind of hard to just measure it by counting. You might be able to. Some of y'all can visualize that better than others. So like if you tried to do that for F, for instance, it has to be at a perpendicular to this line. So it'd be here. So we'd go 2.5, half, 1, 2. So there would be your F. Okay, and remember, I also showed you on the front, really, once you have one of these points, you can kind of look at the distance between the points and do that distance here in your reflection. That's probably better for translations because reflections, you have to think about the opposite direction. But let's see, D looks like it's 1, 2, 3. So go 1, 2, 3 along that angle. So there would be D prime. And then E, if I'm coming at perpendicular to this line, 1, 2, 4, 1, 2, 4. That would be E prime. So then you can see my parallelogram is reflected across that line. Remember, with a reflection, it's the mirror image. Just like if I folded it on that line, all this, the C and C prime would match up. The D and D prime would match up. The E and E prime and the F and F prime. Okay, and that would. Okay, so it looks like we've done that accurately. But algebraically, this is what I'm getting at that I think is easier for most of y'all in a situation like this. Oh, that's supposed to be a pen, not a line. So my original points, B, D, E, and F. would use the reflection across the line y equals x rule, which says your xy becomes yx. And again, that's not something you have to have memorized. That's something that will be given on the formula chart. Y'all have these rules in your notes to use. Okay, so if I use that rule, these points, d prime just switches to -1, 2. D prime switches to 1, 7. E prime switches to -2, 6. And F prime switches to -4, 1. Which you could check, these all meet those points. So graphically I did it, algebraically I did it using the rule. Now I have to do part 2, which is to translate, okay? I'm sliding. Okay, so sliding left 3, because x minus 3, x is left or right, and since it's negative, it's left. Y is up and down, so since it's negative, it's down. So I'm going to slide each of those points left 3, down 7. So you can pick whichever one you want to start with. So if I start with F here, I'm going to go left 3, down 7. So that's my new F double prime. And if I did the same thing with C, and actually let me put that on here with a dashed line. I went left and down. So I reflected or flipped. And now I am sliding. That's a translation as a slide, left and down. And then you would do that for each of your points. Left 3, down 7. So let's see, double prime. Okay, or you can do the once you have one or two of them moved, remember you know the distance between C to D is over 2, up 5. You could do that from your new C. Go over 2, up 5, and there's your new D. Okay, D to E is left 3, down 1. So from my new D, I could go left 3, down 1. There's my new E. Okay, so you can do it that way as well. Let me put these line segments on here, and you can see that parallelogram. From black, it was flipped or reflected to the blue, and then blue to green, it was translated. It slid down and over, went left and down to get to the new points here. Okay, now algebraically, if you don't like doing it graphically like that, and then listing the points, the rule says subtract 3 from your x's. So I would take all of those and subtract 3. So -1 minus 3 is -4. +1 minus 3 is -2. -2 minus 3 is -5. And -4 minus 3 is -7. And the y part of it says, okay, take your y's and -7. So I would subtract 7 from all of those y's. So +2 minus 7 would be -5. 7 minus 7 would be 0. 6 minus 7 would be -1. And 1 minus 7 would be -6. And these here are the same points algebraically as that we got over here. This is at -2, 0 for the D, -5, -1 for the E, -3, no, excuse me, -4, -5 for the C, and -7, -6 for the F. That all meets up. Okay, so whether you prefer algebraically like this, using the rules, okay, or graphically, actually making the movements on the coordinate grid. Both of them get you the same answer. Okay, so I've got a recording with 1 through 3 done, and now this recording shows 4 and 5. So you didn't have to do them all with me in class. We just did a few together. But if you want to go back and do more, you could go back and watch the videos of the ones we didn't do together. Okay, and your practice is here. A 6.4 practice. Oh, I didn't link it in the calendar yet. I'll fix that. But you can either go to My Learning, you can go to modules, or you can go to your assignment lists, any of those places, or probably shows up on your to-do list over there as well. But you have the assignment for today, the 6.4 practice. It's a Delta math. And so you can be practicing that. A few of you are still missing some past Delta math from 6.1 through 6.3. Okay, so you can get those done. I'm going to be putting your quiz grades from yesterday in to Skyward, and tomorrow in class, we'll be working on corrections to those. You'll be able to get points back if you didn't do so hot on that quiz. We'll be correcting it tomorrow.